that you have to find out the velocity, the uh, given is velocity and the angle. Find out the horizontal distance, which we also call some in some problems the range of projectile. Okay, the range of projectile or the horizontal distance, it is the same thing. And it travels. And also the second thing is the landing velocity. So when it lands at location C, what is the velocity? And if I go back to this previous slide, I just mentioned earlier that at any instance, here, 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 even at the point where it lands, you have to find out two components of velocity, correct? and and this is the same method. So, and you already have understood that the uh, first component, like initial velocity, that horizontal component, it is the same as that of at any instant. So at any instant you can use the same component because the velocity in the horizontal direction remains constant. This is what we learned earlier. So let's do this math. So let me start from this equation number equation number 2. Equation number 2 is in x direction. In x direction, let's write it down, the same equation in x direction. X is equal to x a, because the starting point. Okay, let me remind you that the origin is point A. Okay, this is important that you should pinpoint the origin first. It will help you for finding the remaining points. Where is the projectile at a certain point? If you mark the datum line passing through the x-axis, this will be very helpful to you. Okay, now x direction, if I am interested in location xc, so this is my xc, and the question, the equation says y equals to y. This is the in the y direction, but I'm gonna write down in the x direction, which is VAX. Since I mentioned that for the equation you have to consider all the x components of velocities, and t goes from A to C. What is the third component? If you forgot, if you can remind me, what is the third component for the x direction? Exactly, the x direction, acceleration in the x direction for a projectile motion is considered as 0, since the velocity in x direction remains constant. You can give this fact in your notes. Why is it considered as 0 acceleration? Constant velocity has a 0 acceleration. Okay, now let us plug in some values to see where are we at. Sometimes we need another equation to find out the answer. So xc is one unknown. What is xa? If you closely look, what is the location at point A? What is x distance? 0. It is the origin. Okay, so therefore you will write down 0 in place of xa. So that will simplify your problem. Okay, now the next thing is vax. Now what I'm gonna do I'm gonna show you, this is the vertical axis and this is the horizontal axis of velocity. What is this equals to? Vax. So I can write down. Can you tell me what is Vax in terms of sine or cosine angle? 10 cosine 30. Agreed? And time, we do not know the time, but we can find it out from another equation. So this is another unknown. And what else? We don't have anything else left. So there are, this in equation 1, there are two unknowns: the range, which is xc, and the time of flight from A to C. But let's go to the next equation. I'm gonna use the same equation, but not for x direction, for the y direction. Let's apply the same equation to find out our time. Okay, now you can help your professor to open your calculators, start doing some work. Y equals to ya. This is a y, so we want to know yc. Okay, yc equals to v ya plus plus VAY time from A to C, negative 1/2 gravity time from A to C, and square. And gravity value in SI system, do you remember? 9.8 meters per second square. Some students write down double decimal places. This is equally correct. You will not get any deduction if you write down 2 decimal places. It's up to you. Okay, now let's write down. Now you can tell me, look, over here, the datum line is passing from A and through C. What is the YC value with respect to the datum? Yes, it is 0. It is not above or below the datum. It is passing through the datum point. So YA is 0 and YC is also 0. You got my point? That's the benefit of drawing a datum line wherever it passes, so you can calculate the remaining point. So now I'm going to write down left side. This is 0. I'm going to write down this is 0. Let me rewrite here. And what is YA? 0, because A is our origin. In this situation, A is our origin. And what is AY? VAY. 10 sine 30 times T AC. Negative 1/2 times 9.81 times T A to C square. Let me draw a line here that it is not a part of the question. Now I need your help. There is just one equation, one unknown. So we are happy. Why are we happy? Because equation will solve one unknown. So can you do me a favor? Open your calculators and find out the answer. Everybody should try, and we will compare our answers. By the way, I can write down the answer here, but I just want to make sure the answer which you get, it is matching with this answer. You got the same answer? So one student has already found the answer. It is verifying. Okay, verification has been done. So let's move forward. Let's move forward to the next part. We have found the time, but let's plug it in equation number 1. Okay, XC. Now it is very convenient that we have one unknown, which is XC, in this equation. 10 cosine 30 times 1.02. Can you see what is the answer for this one? I got 8.82. That's what you get, right? It's not difficult, so I'm just trying to save time. That's what is more important right now. Okay, now the next thing, we have found the range. Have you understood the first part of the question? We have found the range of the projectile, and the range has been found from the distance formula in the extraction. Range will always be found for the distance formula in the extraction, and the time is usually found from the second. It's the same formula for the y direction. You will see, notice it. So keep it in mind. You will practice. I'll give you some problems to practice, and if you are not busy, you should practice. Are you busy? Very busy. Okay, now what is VC? Now we know that VC is what? We know that VC equals to, always take the two components magnitude formula, which you learned in the curvilinear coordinates, correct? And we already know that the x component is always constant. Look, I wrote down this fact. And what is VAX? VAX, that is equal to VAX, that is equal to VA cosine 30, 10 cosine 30. that is equal to, what is that equal to? 8.86. Yeah. 8.66. I'm sorry, this is not. And now that is also equal to VCX. We have found the first component which was there, but you just had to apply it. Have you understood this step, guys? Now what is VCY? Look, there is an equation in the kinematic. This is the kinematic equation for person. Which one would be useful? First try. If sometimes if it is if you don't get the answer from the first equation, use the second equation. There is no problem. Try to spend time, but it will help you to practice, apply that. So I'm going to suggest you, let's find out the final velocity from this equation. You agree with me? Yes. Right? Let us apply this equation to find out the final velocity. You got it? One student has already found the answer. So let me write down the equation. Final velocity VCY equals to initial velocity VAY minus G time from A to C. VCY is unknown, and look, just one unknown. Everything is known. We are happy. Are you guys happy? Yes. I'm happy too. So let me write down here the 10 sine 30 minus 9.81 times 1.02. Just do the math and find out the answer. Do you get -5? Yes, -5. And now we are in a good shape that we have found both components at location at the landing point. Both components have been found. And now you can apply this equation to find out the final answer. What is our final answer? You will help your professor, and I'm going to write down it over here. I got 10. One student got 10, so I got 10 too. So this is now both answers have been calculated.